Okay, so today's session is, it's quite a mouthful, DELWP. I've been told reliably it's DELP. Silent W, you just say DELP. So it is the Department of Department of Environment, Land, Water and Planning. So it's called Investing in Asset Wealth for Public and Community Benefit. Okay, so this session is presented by Bulletproof. Bulletproof are a gold sponsor of the AWS Sydney Summit, and we have Giles Bill and Sam Mason from Bulletproof with us today. Along with Giles and Sam, we'll have Alina Moyson from the Department of Environment, Land, Water and Planning, so DELP. Okay, so a bit of background info. In the last 10 years, DELP has actually procured 0.5 petabyte of data. That's aerial photography, satellite imagery, point cloud data, and they estimate it's worth about $45 million. So this talk is largely about how they're implementing data science strategies to successfully sort of integrate all their systems and use that data. So without any further ado, can I welcome to the stage Giles, Sam, and Alina.
Oh, thank you.
Nice one.
Hello and welcome to the Department of Environment, Land, Water and Planning's Data Lake presentation, Investing in Asset Wealth for Public and Community Benefit. Today we're going to show you how investing in a data lake has enabled DELP to open up new data in new markets, to redeploy 2 of their staff members, and show you how they can now deploy internal projects up to 3 weeks earlier than previously. But first, a little bit about Bulletproof. We are the leading cloud services provider in Australia and New Zealand. We've been in business over 17 years. Listed on the stock exchange in 2014, got over 120 employees, over 700 customers, so we've got a few scars. We've got offices in over 5 locations in Australia, New Zealand and the United States, and we've got a pretty healthy fin-year revenue for FY16. But Bulletproof is about cloud-empowered digital transformation. We work with customers at whatever their level of maturity to help them deliver their desired business outcomes through cloud-empowered digital transformation. From the first steps to the cloud, to cutting-edge innovation, to what we're going to talk about today, data lakes, our approach is methodical, pragmatic, and delivers results, helping you to migrate, scale, optimize, and innovate. In a moment, Alina's going to start with where DELP found themselves and some of the issues that they faced. Then I'm going to cover off what a data lake actually is, and then Giles will run through Bulletproof's data lake solution with a detailed architectural overview. And then Alina will share with us some of the key learnings and what we can expect in the future. So like all stories, let's start at the beginning and hand over to Alina.
Thank you, Sam. So in late 2015, the Department of Environment, Land, Water and Planning, or DELWP in Victoria, launched our Digital First program internally. The goal was to transform the people, processes and technologies that would enable DELWP to become a customer-centric and tech-savvy organization. One of the key priorities for the Digital First program was to build the ICT foundations that would enable us to have mobility, collaboration, analytics, and knowledge management. As you can see in the slide behind me, DELWP delivers a very broad portfolio from land titling and valuations to protecting the state's wildlife and heritage to doing planned burning and emergency management across 4 million hectares of public land. But perhaps from my background as a geospatial professional, I would paraphrase all of that to say that we are the Department of Spatial Information. Everything that we do is dependent on spatial data related to distributions and models. And this is a tremendously exciting time for us because every day new location-enabled sensors enter the market. We have a rapidly densifying satellite constellations above us, and just this huge wealth of new spatial data coming at us. And it's revolutionizing our ability to model and monitor our environment in real time and to high accuracy. These new technologies are rapidly moving us from modeling the real world and representing the real world. For example, a road line on a paper map is a representation of the real world, to actually being able to record that world in very high accuracy, where you would get that road in 2 centimeter aerial imagery resolution, available as often as you wanted. And this is presenting to us, as it is to nearly every data-intensive organization, some very fundamental challenges. At present, DELWP holds a 0.5 petabyte of aerial imagery and point cloud data, spatially enabled data. And I'm sure that this audience is fairly well versed in data sizes, but I always find it's helpful for the imagination to put that in the terms of DVDs, number of DVDs. So at the moment, we hold 100,000 DVDs of spatially enabled data. By 2025, we will hold at least 500,000 DVDs worth of high-value spatial data. And this increase is driven by improved sensors, improved data modeling techniques, and new types of data collection available through drones and the Internet of Things. But our ability to manage that data in the back end has simply not kept pace. Our appetite is bigger than our stomachs, and we find that we must radically re-engineer and re-architect the way that we store and manage those data resources in order to take advantage of that data wealth. It's critical to all of the many services that we deliver that that data continues to come in. Oh, whoopsie. But meanwhile, the way that we service this data internally and to external customers is inefficient, inadequate, and highly disjointed. Now is the time when I have to admit that my DVD metaphor is actually not very far off how we are actually storing data, which is on disconnected hard disk drives and LTO tapes. We have no central storage solution, no centralized and complete catalog of our assets. And to get a data set back from our archive takes at least 3 weeks. And that's best case scenario because it means you knew where to start looking. It's difficult for us to search, discover, and utilize and understand the data that we have, or whether it's fit for purpose. We duplicate efforts in recreating data products because we can't find or locate our existing data sets. Furthermore, as this data goes through its various stages of processing, from collection to QA to distribution, again, the main method of distributing that data is on hard disk drives. So if along that process the data becomes corrupted or we lose it, the team has to go back to a previous point of storage and rebuild the data again. And again, that causes delays to delivering the final product to customers. And overall, it's a very lengthy, complicated workflow that involves numerous individuals across the organization and no self-service for users. Finally, we're unable to efficiently respond to legislative requirements and inquiries. And most importantly, all of the relevant data that we have isn't used to make decisions because analysis of very large data sets, particularly using automation, is impossible using our current infrastructure constraints. So the result is poor analyses and more time for staff to make manual interpretations. It's not hard for anyone to see the risks of this situation. Until recently, cost has actually favored using hard disk drives and tapes. Even though at scale, the costs enormously for wasted staff time on low-value manual storage tasks. It's the time spent on that inefficient activities that actually represents a very large and growing cost, but one which is often hard to see because it's spread throughout the organization. Our system is also highly reliant on key personnel, and this was illustrated beautifully when business analysts found that our data archive system was at least partly dependent on the holidaying habits of one of our staff members who would take tapes to the archive on the way to his vacation home. And that's the kind of ad hoc, helpful thing someone does when they think they're filling a temporary need that, as the scale gets bigger and bigger, is just simply overwhelming. And of course, data silos are difficult to search and manage. You can't apply enterprise-wide security standards to them, and you risk data loss and corruption. Finally, the inability to scale means we can't do the processing that we really want to do across all of the data that we have. So valuable knowledge isn't applied to decisions, with the risk that those decisions are wrong to the detriment of the communities we serve. So with all of these problems, what's the solution? We spent a year internally gathering requirements, but we still had no idea what we were really looking for. Was it going to be sufficient for us to just migrate to the cloud? Did we need software? What kind of software? So when we brought in Bulletproof and they very quickly started to talk about data lakes, our question was, of course, what is a data lake? So I'll hand back to Sam now to discuss that in more detail.
Right. Thanks, Elena. So, data is a problem. You all know this, that's why you're here today. If data wasn't a problem, we wouldn't need a cloud. We wouldn't have a summit, and we could all go home now. Data's a problem, and it's a problem that's going to get a lot worse. 90% of the data out there today is less than 2 years old. Now, Gartner predicts that by 2020, we're going to have over 1 million new devices coming online every hour. Now, we already produce over 2.5 quintillion bytes of data every day now. So the volume is only going to increase. And of that data that's coming in now, 90% of it is unstructured, semi-structured data in the form of binary memory dumps, Parquet files, machine learning models. We've got video, audio, geospatial assets, you name it. It's in JSON, XML, Parquet, financial reports, the lot. And here's the great thing, with all this data we've got coming in now, we still can't find anything. Is it any wonder that 1 in 3 business leaders don't trust the data that they have today anyway? So why? Because our traditional tool chains and architectures, due to cost and time constraints, force us to make too many decisions far too early in our data collection pipeline. And as a consequence, it's harder and harder to integrate new data sources and ask what-if questions downstream. One of the things about this is this prevents us from doing experimentation, exploring, sharing and discovering our data across the enterprise. So we're making too many decisions too early in the pipeline. So the solution to this is to turn this problem on its head. Instead of deciding what data sources we'll integrate, what level we're going to aggregate at, what subset of the data available we're going to collect and store it in on-prem expensive solutions, we're going to grab all of it. A data lake is an enterprise data repository and a cloud-based architecture. We take all the data and we store it raw. To do that, you're going to need a low-cost, scalable, durable, and above all, secure medium, such as Amazon's S3. And by doing this, you keep your storage and your compute layers independent. This, of course, also gives you centralized security for enterprise-wide data governance. But you know, all of this is great, but it doesn't help if you still can't find the data. And this is the key part of a data lake. A data lake is driven by the catalog. Catalog is what allows us to search, discover, publish, and share data across the enterprise. Every time we add something into S3, we extract metadata out of those objects and store it in a centralized index. This becomes the primary interface through which your people in your company access your data, and once they've done some work with it, they publish it back to the data lake. Because we store all the data raw, it means we're not making decisions upstream about what the data means. We leave that up to the consumer of the data to decide what that data means, because we delay those semantics until use. With tools such as Spark, Hive, Presto, and hopefully Athena one day in Sydney, we'll be able to, and we can now with that, we can query those data sets in place without having to engineer expensive ETL processes to pull them in before we can do any work with it. And of course, integrating new data sources is as easy as getting them into S3. A data lake is a completely different culture. It's when you start to think as a company about investing in data wealth, stopping people doing the same work again and again. Somebody does some work, they publish it back to the data lake. People on pub/sub models can subscribe to topics of interest, and they can find this data and help dissolve the corporate silos. And this, of course, you get all of this at a far lower total cost of ownership than you get in traditional EDW solutions. A data lake encourages experimentation because you don't know today the questions that you want to ask tomorrow. And also, if you have a data science team come in and run a 4-day machine learning algorithm, it doesn't bring down your production systems. For the same reason, it reduces risk. You get the 11 nines durability of S3, and it keeps your data scientists away from your EDW. It also gives you reduced time to insight, allows you to detect and respond to changes in market behaviour as they occur. So this whole collection of data concept raises a number of questions that we all have to answer. Questions about consumption, questions about ingestion. With ingestion, how do we apply policy-driven security? How do we do enterprise data governance? How do we handle scalability and concurrency? How do we handle exceptional conditions? How do we handle any domain-specific requirements there may be on how we ingest that data? And then on the consumption side, we have how do we make sure that only the right audiences get the data and see the data they're allowed to see? So how do we monitor and audit access? How do we handle any domain-specific querying that there might be? And most importantly, how do we find this data once it's all done? So the answer to all of these questions is a data lake, and as Giles is about to show you, Bulletproof's answer is Bulletproof's data lake solution.
Thanks, Sam. So, as we've heard from Sam, the principle of a data lake is to index and store data in its raw form using low-cost storage. So what does our solution actually look like, and how does it work? So let's have a look at the AWS services we used. S3, building block of a solution, low-cost, fully redundant, durable object store. S3 buckets can be secured, accessed, tightly controlled and audited. And our solution utilizes S3 eventing and object lifecycle management. DynamoDB, acting as our metadata catalog and basically an index for our data lake. It's a fully managed, scalable, NoSQL database. Its schemaless design ensures we can accommodate future functionality, including support for complex geospatial search and support for fine-grained data security access. EC2 hosts our component services which do things like apply business logic and rules, wrap data access services, intelligently trigger workflows, and expose RESTful endpoints. We'll discuss a bit more about this in the next slide. Simple workflow service. So we use this to manage our ingestion flows. Simple workflow is a distributed processing engine to manage orchestration and state across concurrent workflows. In-flight workflows can be queried via the API or via the AWS console. Simple queue service allows us to decouple our component services, ensuring they can independently scale. API gateway, so our consumption services are exposed as APIs through API gateway. This ensures they can be properly secured through authentication and are versioned and discoverable. Monitoring and audit is through CloudWatch and CloudTrail respectively. And we use Snowball for large data transfers, mitigating issues around security and network latency. So this is a bit about our component architecture. Excuse me. But before we do, an explanation of what a bundle is required. A bundle comprises multiple assets, with an asset being a single object stored in the data lake. Bundles keep related assets in the data lake together, where separation will break consistency or interoperability. In DELWP's example, many geospatial objects are accompanied by metadata files that indicate the spatial projection or datum. Failing to download these asset dependencies makes it impossible to correctly load into GIS software. Extend this concept and you can see how it's equally applicable across a variety of domains and use cases. Bundles themselves are described by a bundle manifest. An example of what we can see here is basically a JSON file describing the assets comprising the bundle, bundle security attributes, bundle publishing status, and the initial S3 storage class for the asset or assets. So let's look at the ingest component service. They're deployed as stateless RESTful Java 8 services. They're deployed across a multi-region auto-scaling group, and they use the AWS SDK for Java. We also use the open source GeoTools library for extraction of geo-specific metadata. We expose business service endpoints to our API gateway and to other services. And scalability, and thus concurrency, is handled through monitoring the size of a simple workflow task list. Interestingly, our asset keys are always ensured to be unique. This ensures that they are distributed across multiple S3 partitions, optimizing reads as our data volumes increase. We persist the original file name as a S3 object attribute. So our data store service. the consumption service. Again, deployed as a stateless RESTful Java 8 service deployed into another auto-scaling group. It basically wraps DynamoDB access, constructs and optimizes database queries, caches and returns page results, enforces data level security, creates signed URLs with configurable expiry times, and exposes endpoints for API gateway integration. So here's a typical ingestion flow. Bundle assets are uploaded to an S3 bucket. The object created event from S3 is published to an SQS queue. The ingestion service dynamically triggers workflows based on the SQS payload and applied business rules. The workflow is triggered and the bundle processing begins. First, to check for duplicates using a hash of the asset. Assets are then copied to a QA bucket. File metadata is passed if necessary. A catalog entry is created in draft status. A designated user or group is notified that a draft bundle exists and is ready for publishing. The bundle is approved and corresponding metadata catalog entry is set to published. The bundle is copied to the data lake based on the specified S3 storage class. And finally, the bundle is removed from the ingest and QA buckets. At any time, an exceptional condition can occur, processing terminates and users are notified. So a consumption flow. I don't think there's anything too surprising here. Consumer queries the metadata catalog using an authenticated API call. The request is proxied to the data store service. The data store service creates a query and executes it against DynamoDB. Query results are cached and returned. The consumer requests a specific bundle from the page query result. The data store service constructs a signed URL with a configurable expiry time for each asset comprising the bundle. The consumer issues a read request directly against S3 using the signed URL. S3 streams the assets to the consumer. All our component services are developed, tested, and deployed using a battle-hardened CI/CD pipeline. All AWS services from the VPC up are described and built using CloudFormation. So that's about it at a very high level. I'll touch on some of the new features coming up after Alina's wrap-up.
Thank you, Giles. That's great. So this has been a huge learning experience for me and for my whole department, and I'd really like to pass on any small amount of wisdom I can to those who are also taking their first steps into the cloud or who help initiate clients to the cloud. So first of all, I was sure that I had a greenfields project. There was no current solution, there was no current service really to speak of. But what I've learned is that there's no such thing. Legacy environments and legacy thinking are baggage that you will have to deal with in either building in or migrating to the cloud from a traditional infrastructure approach. It's critical that you bring people along with you on the journey and manage that change proactively and at all levels. For DELWP, this is the first enterprise scale cloud project that we're putting in. And so for us, we've actually had to push through a lot of the barriers, both technical and organizational, unfortunately. And some of those can be very time consuming and have nothing to do with the tech. I recommend establishing an internal cloud user group who works to sort of discuss broad requirements for cloud, discuss point solutions. It can be used as a training group, and really, at the end of the day, become the evangelist that you need to have in an organization to prepare people for the changes that are coming. We also found that there's great benefit in taking a proof of concept or pilot approach, which is so easy to do in AWS because you don't have to invest huge sums in equipment or take out lengthy contracts. And what we found is that we gain a lot of clarity in what the barriers are going to be and how much extra cost and time that we need to consider by taking short, sharp, and cheap proof of concept exercises. It also frees us up to have a more open-ended discovery phase in which we're not expected to have all of the answers right away. And so the answers that we do get tend to be more innovative and novel. And of course, that's dependent on having the right expertise with you to bring you along on that journey. The benefits to DELWP start with having that infinite, secure storage that is easy to access. That was our most significant barrier. And from this, we have released 2 full-time staff members to do other duties who had been engaged in supporting and managing our legacy archiving system. And that wasn't really using their expertise or skills appropriately. No one wants to be spending a large amount of time copying data. In fact, what we have found is that no one, beyond maybe us, wants to think about storage at all. If it crosses a user's mind, it's because something is broken. What they want is storage that works, that scales as big as they need it to be, and where they never ever feel like they're losing something in an amorphous black hole. The other thing that we've benefited from is being able to access data faster. So from 3 weeks with our old archiving system now to a maximum of 5 hours. And once that data has been recovered, we can then automate processing jobs to start so that our analysts stay focused on improving data models and interpreting results and not on watching processing clocks tick over. And finally, this system will enable DELWP to share our very valuable open data with communities and also with the market, who can use that to underpin new products and services, many of which we can't even predict right now. And that will be very exciting to see. So once we've solved the access question, the next thing is to actually start to look at what the value of our data is and assess that and get insights into that. So when we figure out who's accessing the data, why, what they're doing with it, when, and for how long, we can use that to develop a data lifecycle strategy that is built on real usage. It will inform us, for example, about what's an appropriate length of time to keep some of this data based on the demonstrable community benefit measured against the cost of retaining very large volumes of data indefinitely. We also strongly intend to take an agile and DevOps approach with a product backlog that determines the next development and release cycle. This is important to us because I think it's no secret that government has a terrible track record in developing and delivering IT projects on time and on budget. I'll use the NBN as an example. And taking an agile approach allows us to say that while we may not deliver every function that we have ever conceived of, we will get the most critical features and we will get those right away so that we can start to release the benefits from those things. And we'll have a plan for addressing those less urgent requirements in the future. This is a very sane way to go about developing major IT projects. So I really recommend you save your sanity and build in flexibility that allows you to deliver your most important functionalities first. Back to you, Giles.
Thank you, Alina. So what's next for the solution? Let's have a look. So, an intelligent web-based ingest client and CLI, improved import automation for bulk asset ingest, ingesting from additional data sources, using high-performance compute processing clusters for on-demand data processing, incorporation of external systems into ingest workflows, intelligent analysis of data usage to optimize storage class and reduce costs, expansion of a data lake to harness other data stores, enhanced reporting and audit, and the potential to monetize data access using the API gateway. Architecturally, we're looking to move to containerization using service discovery and container lifecycle orchestration, and the implementation of a configurable business rules engine. So I hope that's given you a good understanding of how the solution fits together and how the data lake underpins DELWP's overall data strategy. So just to round up, whether your organization is still defining its cloud strategy or you're seasoned veterans, Bulletproof can help from our introductory cloud adoption packages to design and implementation of next-generation cloud architectures. We also have a comprehensive Agile and DevOps engagement model spanning assessment through to implementation and coaching. Other offerings cover cloud optimization, data integration, data strategy, such as the one you've just heard about, and these outcome-focused engagements help you achieve cloud-empowered digital transformation. As always, Bulletproof are able to provide ongoing support for everything we offer. So please come by our stand G13 for a discussion on any of our products or services or to discuss this solution. And you can also enter and win a Parrot drone, which is excellent for geospatial analysis. Also, AWS will be running a data lake presentation directly after this one in the shape-shifting room. So with that, thanks to Sam, A big thanks to Alina and to DELWP for their support, and finally thank you all for listening.